on this screen here, what I've got is I've got y equals ax squared plus bx plus c. That's our general quadratic function. A, B, and C we've discussed before are real numbers. A cannot equal 0. And the first thing I'm going to ask you guys is about the concavity, whether it's concave up or concave down. You guys that have had an Algebra 1 before, you will have heard me say, is the field goal good, or are you joining the swole patrol? That's our phrase. And it all has to do with what's called the leading coefficient. Landon, I'm going to hit you up. Leading coefficient test. What if A is positive? What's that parabola going to be doing? Good. It's going to be concave up. So that parabola, you know, will be doing something like that. And if A is negative, what do y'all think? Concave down. And that's really in Algebra 2 trig and in pre-calculus, you learn about what's called the end behavior. The leading coefficient here for this polynomial function tells you about the end behavior. It's an even degree function, and so its end behavior is going to be pointing in the same direction. If A is positive, field goal is good, or smiley face, it is a positive thing, upwards. And then if leading coefficient is negative, you know, it's concave down, swole patrol, the weight room, million watts is that way. Okay? So that's called leading coefficient test. That's how you can real quick, real easily determine concavity. So for this example over here, on the sideboard, I've got this example. We'll look at it in red here. Y equals x squared minus x minus 6. Nick, you would tell me that's concave up. Concave up. Because A equals 1, I know this one's going to be concave up. I know that parabola is going to be doing something like that. Now, I don't know anything else, but that's a pretty rough sketch right now. You know, but at least I know that it's gonna be looking something like that. Okay. Now, second thing on our list is called the vertex. Now, the vertex. Somebody give it to me in your own words. What does the word vertex mean to you regarding a parabola? Who wants to put it in their own words? I don't care what you could sound awesome or you could sound like a goober. I don't care.
Where it beats the
Okay, so not a bad thought right there. Like this point, and this point. Those are called our intercepts, Zach. And we're going to hit those up in just a sec. Those are our X and Y intercepts. Not a bad idea at all. Somebody else, Mr. Barron.
like the top of the bottom.
Oh, yeah. The highest of the high or the lowest of the low, like right there or right there, for instance. Okay, Chase? A solution? We'll kind of get in more, like if you use the word solution, probably more talking about like those are our roots right there, our x-intercepts, our zeros are our solutions. But let's kind of go back to this notion of the lowest of the low or the highest of the high. In calculus, we would call these extreme values, or the plural form of the word extreme would be extrema. These are extrema. Specifically, this one right here is called a minimum value. This one right here is called a maximum value. It's like the lowest point on the curve. That's called a minimum value, a global minimum, or a extreme value there. And then conversely, if it's the highest point on the parabola, it's the maximum. It's the highest point up. The technical definition that I'll give you guys of what a vertex is for a parabola, a vertex is the point of intersection between the curve and its axis of symmetry. Can I say that again so you write it down? The vertex of a parabola is the point of intersection between the curve. Ooh, that's a nice parabola right there. Look at that. That is pretty. Yeah, it's the point of intersection between the curve and its axis of symmetry. So there's the curve, aka the parabola. And this is its axis of symmetry. Now, I married a beautiful and wonderful lady. She sometimes makes fun of me. I got a little droopy eye action going on over here. Okay, I think it's this one. This one. Which one's a little bit lower? Got a droop. That one. Yeah. Anyway, she makes fun of me sometimes because of my droopy eye. My face is not symmetrical, right? Okay. But the idea of symmetry, like if my face was real symmetrical, it would be what? What does that mean?
See the same.
Yeah, same on both sides. So a parabola is very much symmetrical. It's got a line of symmetry, goes straight down the middle. What do we call the point of intersection between that axis and the parabola itself? We call that the vertex. All right. So the point of intersection between the axis and the curve, that's the technical way of referring to the vertex. And the vertex is a point. So guess what? The vertex has an x coordinate and a y coordinate. Okay. So if somebody said, hey, here's this quadratic function, find its vertex, they might know what to do. They might know how to find that vertex. Got any ideas?
On the intercepts.
Oh, very nice. You could find the intercepts and split the difference, the x-intercepts and split the difference between the two of them. That's a very valid way of doing it, right? Like you find half of that distance, and then there you go. And that's the x coordinate of the vertex. And then how would you go about finding the y coordinate of the vertex? Excellent. Excellent, Grant. Anytime we know x, we can find the corresponding y value by plugging it in. Okay. Now, Chase said something interesting a minute ago. What do we call these values again, these x-intercepts? We call them roots, zeros, solutions. Now, how would you go about, like, suppose that instead of y equals, suppose this is 0 equals. Suppose I want to find those solutions, those zeros. How do you guys go about finding it? Would y'all just take a quiz on? The quadratic daggum formula. And could you quote that quadratic formula for me here? All right, beautiful. Did y'all notice how a little something was missing from each one of those options? All right, so we just got through talking about over on the right side of the screen how you could like visually, I think that was Nick's suggestion, you could visually like split the difference between the two roots. Just generally speaking, which root, again, generally speaking, which root is this one on the left? Y'all just gave me two roots. I'm saying which one is the one on the left, generally speaking?
Oh, it's negative. It's not x.
The one with the minus. And what's the one on the right? The one with the plus. You know what I'm saying? There's a plus. And there's a minus. And so how would I, quote, split the difference between two things? That's averaging. How do you average two things? Add them up. Divide by 2. How now, brown cow? Could I do a little bit of, I wonder. Could I take negative b plus square root of the discriminant over 2a, negative b minus square root of the discriminant? Here are my two roots. Could I add them up and divide by 2? You tell me. Does this look too crazy to you? It's about to get real simple. Well, y'all told me to average. To split the difference, to average two things, you add them up, divide by 2. Yes. Suppose that you made an 8 and you made a 5 out of 10 on a couple quizzes. You're going to do way better than that, but I'm just making up numbers. Suppose you made an 8 and you made a 5, and those were the only two grades you had all year long. What would your average be? You'd add them up, divide by 2. You know what I mean? So that's Nick's suggestion is beautiful because what you're doing is you are splitting the difference between the two roots. To find the x-coordinate of that vertex, to find the axis of symmetry, you split the difference between the two roots. In other words, you add them up, divide by 2. Now this looks real convoluted, but it's not. It really isn't. Is the denominator the same? 2a and 2a, is that the same?
Yes.
Yes. So we can add those two fractions together. All right. So let's see here. We got negative b plus square root of the discriminant plus negative b minus square root of the discriminant all over 2a. Okay, y'all rolling with me? Everybody cool with that? We literally just added across the top. And now simplify this numerator for me. What's plus square root of the discriminant and minus square root of the discriminant going to do to each other?
Cancel.
They're going to cancel each other out. And what's negative b plus negative b? So I got negative 2b over 2a. What's going to happen to those top twos? They're going to cancel out. So I got negative b over a divided by 2. Now, dividing by 2 is as easy as pi. Just flip it and multiply. Flip what? Flip that bottom fraction. Keep flip change. Make it 1/2 times 1/2. Or you can use the compactor method. Have we talked about compactor method in here? Oh, baby, I love the compactor method. Does anybody have a trash Sorry. You're welcome. Does anybody have a trash compactor in their home? Or maybe your grandmother's home? No? Do y'all know what I mean by trash compactor? All right, trash compactor. My mother and father had one in their house. It's like a piece of technology from the 80s, probably before then. Let's see here. Trash compactor.
Welcome back to our YouTube channel. Today we're going to show you how to use our trash compactor. Sizes can range. Then you'll turn your knob where it says start, and there you just put on.
You put trash in that box, close it in there,
And there, you shut the door.
and it smashes the trash can.
What it's actually doing is it's filling.
That smashed all the stuff down. Now that might seem like the dumbest piece of technology you've ever heard because you could just use your what? You could just use your foot, right, and squish it out. But like, what if you had a bunch of nasty stuff in there? You didn't want to smash the trash down with your foot, you know? Anywho, do what? Use your hand. So anyway, the compactor method is something I like to say. When you've got a fraction on top and a non-fraction on bottom, what you could do, watch this. You could just squish that guy. He goes and squishes that down. You know what it becomes? The opposite of B on top. And where did A go? Yeah, 2A down at the bottom. All right. So the long and short of it is, I didn't do this with second period today, by the way, but I am doing it with you guys. We just derived how you could find the x coordinate of the vertex of a parabola based on just the coefficients. It's the opposite of B over 2A. Now, am I going to expect y'all to do a derivation like that by yourselves? No, but it is very useful to kind of get your head wrapped around the fact that, oh, snap, if I know what A, B, and C are, then I can very quickly and easily find the vertex.
Does it matter which way the vertex? Facing.
Well, it does. That's why we talked about concavity first. You mean as far as whether it's the minimum or the maximum?
Yeah, would it still be?
That's determined by the leading coefficient. And so for our little example right here in red, because we knew it was going to be concave up, let's go ahead and find its x coordinate, the opposite of B over 2A. Zach, sorry, go ahead. Oh, yes. And you know what? I don't know why I'm picking this thing apart. What's A? What's B? All right. And so if I wanted to do the opposite of B over 2A, so guess where the x coordinate of our vertex is? It's at 1/2. Now, how you go about finding that? Y coordinate, what did Grant tell us a minute ago? Plug and shove. Now, that means I've got to plug in a fraction, and should I be scared about plugging in a fraction? Not at all. We just use parentheses and do the arithmetic. Y'all do that with me. What's 1/2 squared? Good. We got 1/4 minus 1/2 minus, let's go 24. 24 fourths. How about I turn 1/2 into 2/4? Just making common denominators here. So what's 1 minus 2 Is that negative 25 fourths? Or negative 6 and some change? Negative 6 and some change. So 1, 2, 3, 4, 5, 6. 6 1/4. Right about there is my vertex. Okay. How did we find a half again? We used our formula, the opposite of B over 2A. As I was telling the class earlier today, it's the opposite of B over 2A is your X coordinate. And then the way that you find your Y coordinate is just plug and chug into the function. Whatever that opposite of B over 2A is, just plug it into the function. So if it's an easier problem, like this one was a fraction, and we kind of, okay, I don't know if I like that. If it's an easier problem, let's see here. Let me skip over. I've got a whole bunch of these examples we looked at. Yeah. Look at this one right here. What's the opposite of B? The opposite of B would be 12. What's A? A is 1. So 12 over 2 times 1, 12 over 2 is 6. So we got that 6 value, and then we just took it, we plugged it in, and we worked out the arithmetic, we got the corresponding Y value. So we know the vertex real easy. Do you know how to find the vertex on your calculator? All right, get your calculators out. There you go. And we've worked a lot of examples. All right, so on the calculator, your go-to screen for graphing is your Y equals screen. So it's the top left-hand corner, okay? Hit your Y equals button. It came with the like handheld calculator. So like when you buy this calculator, I think you get the what you're doing, the emulator. All right, so Y equals screen. Let me just type in my function here. X squared. Y'all do this with me. Minus X minus 6. And then zoom 6 puts me in my standard, 10 by 10 window right here. And that's a pretty good looking little parabola right there in blue. Now, if I wanted to find the lowest point on this parabola, I'm going to hit second trace, and then you tell me which of those options looks like it would do it for me. Minimum, that third option. Now it says left bound, and can you see where that cursor is? I'm going to zoom in for you guys that are here in class. I don't want to sound like smart aleck, but you hit the graph button. Again, I'm not trying to be ugly, but yeah, to get it to graph, you hit the graph button. They make the user interface pretty self-explanatory. All right, so we hit second trace. That takes you to the calculations menu. And then we hit that third option. And do you see where it says left bound? Look at my cursor. As I move my cursor to the left, just make sure it's somewhere over here to the left of your vertex. And if it is, just hit enter. And what it's doing is it's kind of fencing it in, and it's going to find the lowest value that's going to be to the right of that. And now it says right bound. So we're going to scroll to the right. Okay, I'm to the right of my vertex, and I hit enter. And then last it says guess. I don't really care about guessing, so I'll just hit enter a third time. And lo and behold, look at what it says. 0.5 and a negative 6.25. And that's how you would find the minimum or the vertex of that parabola. Zach? 3. Sir. Nick?
That's not letting me graph.
Go to Y equals. Do you have a plot highlighted up at the top?
Dang, are you supposed to get on X?
Go to Y equals. Do you have any kind of plot highlighted up at the top?
Yeah.
Scroll up and unhighlight those plots. Will J, do you have the same thing? Do y'all use these in another class?
A little bit.
The two of you?
Oh, that's the same.
If you've got one of these plots highlighted up the top, plot 1 or plot 2 or plot 3, scroll up and unhighlight those. Because if it's highlighted, as soon as I hit graph, it's going to give me an error, invalid dimensions. That just means that I've got a stat plot that's highlighted, and the calculator doesn't like that, so I'm going to scroll up and unhighlight it, and then I can go back to my graph.
It says, yeah, I guess it's right. I see just 0.499.
Yeah, sometimes calculator will have a little rounding issue. So like, for example, if I tried, if I hit trace, just plain old trace, 0.5 enter, it shows me that that's the vertex.
What might be hit after hit? And draw.
Hit the left button to move your cursor to the left, and then enter. It changes to right bound, and then enter once you get to the right. And it says guess. Don't worry about guessing. Just hit enter a third time. It scrolls. Yeah, it always says left bound, right bound. Yeah. How would you find the first thing? I guess the second calculate, the third option is 3. And then scroll, get your cursor to the left, hit it. Get your cursor to the right, hit it. And then hit it. And fellas, I'm gonna tell you what, that is one of the more useful tools that I've ever, as like a high school student, I use that all the time. Being able to find the zeros, being able to find the minimum value, very basic skills, important skills that we need to make sure we got on lockdown. So that's how you find the vertex by hand. Let's continue on our track here. This is a practice quiz over here on the side screen, sideboard. So we've talked about concavity, talked about vertex. What about x-intercept? Chase mentioned those are called our roots. And how did y'all go about, let me zoom out. How did y'all go about finding the roots again? QF? QF. Yeah, quadratic formula. Although, for this one in red, do I really need the quadratic formula? Why not? Because it factors. And oh, good gravy. Why would I want to bother quadratic formula if this factored? Okay, it does factor. And I'm going to ask Adam Kelly to factor it out for us, please. I don't know why you're saying y. Let's go y minus or x minus 3. And how about x plus 2? There we go. All right. Now, Will J, what 2 roots would that provide me with? Beautiful. And by the way, do you notice the symmetry now? Right? We kind of put the cart before the horse by sketching this axis symmetry first. But we found our vertex, and now we found our 2 x-intercepts. You find the x-intercepts either by factoring and using the ZPP. Adam factored, Will J did the ZPP. Or you could use quadratic formula and get your 2 roots that way. Do you know on the calculator how to find the roots? It's the same process we just used, except instead of selecting the third option, we're going to select the second option, I think. Hit second trace. Yeah, there you go. Look at that. 0. So that means I want to get my cursor to the left of my root, hit enter. Want to get it to the right of the root, hit enter, and then hit enter a third time, and lo and behold, it tells me my x-intercept is -2. Can y'all see that pretty well? And can you practice doing that on your end? Second trace, try again. Second trace, you do the second option there. And just make sure. Yeah.
You press second trace.
2. Just try it again. So I hit enter to get my cursor to the left side of a root. And then I move my cursor to the right. I hit enter to lock it in on the right side of that root. And see what it's doing? It's sort of like fencing it in. It's going to find where does this function cross the x-axis between here and here. And so we hit enter a third time because we don't care about guessing. And it says, hey, look, there's x equals 3. That's your root. Okay. Very powerful piece of technology that you guys can have to help you find x-intercepts. This one factored, though. So why in blue blazes would I use my calculator to find the roots when it factors and ZPP is so much faster? Right? You good?
Oh,
Oh, well, let me come back now. Second. 2. All right, stop right there. Enter. Well, I mean, we're closer to this one, so let's say the circumference. Hit in. And then go to right. Hit in. And then hit enter one. And then it'll show you. And you can, hey, practice doing it on the one on the left. Practice doing it, repeat that process. Then you can figure out why. Which one are we trying to find? We're trying to find the left out? I mean, the negativity. All right, keep going to left. Keep going to left. There you go, stop. Now you're to the left of that root. So hit enter. And then move to the top. There you go. You're to the right. And now hit enter a third time. There you go. So what it has to do, let me draw this up. Fellas, real important, listen carefully. Suppose that I've got, all right, there's my curve, there's my x-axis, okay? And I'm going to try to do, quote, left bound and right bound. So what we want is we want that cursor to be somewhere to the left of whatever that root is. And then we want our cursor to be somewhere to the right of wherever that cursor is, because they're going to hem it in. You might see them drawing those two little triangles. You're finding where between these two boundaries does this function cross the x-axis. And so then the question becomes, well, hey, what if it crosses multiple times? That's where your guess option comes in. You get the cursor on that third one, you get the cursor closest to whichever one you want, and you quote guess there, and that's when it locks it in for you at that spot. Does that make sense, Ben? Yes, sir. All right, let's just say a little practice. You got to pick up on it pretty good. Okay, but here, go back to the notion of x-intercepts. Talk about x-intercepts. How about the y-intercept? Dylan, what do you know about every y-intercept? Every point that's on the y-axis, what do you know about it? Will Plummer, do you know anything about it? Any point on the y-axis has to have x equals what? It's x equals 0. Any y-intercept is going to have, because you're not moving left or right any, you're right there. So how would I go about finding that y-intercept? I'd let x be 0, right? You see, to find the x-intercepts, we had y was 0. So to find the y-intercept, guess what? We're going to let x equals 0. I love this. X equals 0 is so easy to do because you can just cover up any of the x terms. I like to call that the cover-up principle. All right, y'all learned about trash compactor earlier. Now you're about to learn about the cover-up principle. I'm too short to reach this high. Look, these two terms right here, let x be 0. Man, you just cover them up. What is y going to equal? -6. -6 is your y-intercept. It's just that easy to find. And in general, the y-intercept is always your what value? It's always your c value. You might jot that down. Your y-intercept is always going to be that c value. Because ax squared has an x in it. When you plug in x equals 0, that goes away. bx has an x in it, so when you plug in x equals 0, it goes away. Now, we're almost home free. Talk about the axis symmetry. By the way, axis symmetry is what kind of line? Vertical line. Sam, Skrill, what do you know about the equation of a vertical line? Y equals 0, or excuse me, y equals a number, x equals a number, or y equals mx plus b. Sure, not a problem. You know how we can get unconfused. Let's go here. Can I move this down? Minimize. Go to Desmos. Check this out. Watch this, guys. Get out of there. All right, so like y equals 5. What kind of line is y equals 5? Horizontal. Well, all lines are straight. Horizontal. All right. What about x equals 2? Vertical. And then what about y equals, 1/2 x plus 3 or plus, yeah, whatever. That's diagonal. So that's the garden variety lines are either y equals a constant, x equals constant, or y equals an x plus b. So we're looking for a, let me go back to my picture here. We're looking for a what kind of line? A vertical line. So it's going to be x equals some number. And do you know what that number will be? The opposite of B over 2A. So that's because it passes through that vertex that we talked about earlier. So the axis of symmetry, our axis will always be an equation. It'll always be x equals, and in this case, what was it, a half? X equals a half because of the opposite B over 2A. Y'all are going to have a little bit of some delta math homework practice with this, and it's going to like give you an equation and be like, what's the axis of symmetry here? Just say x equals opposite B over 2A, and you're done. And it's just that fast. Okay? That's the axis of symmetry. Man, we're almost done graphing. How many points do I want? How many points do I want on every parabola? I want 5 points on every parabola. One of those in the middle needs to be the what? Needs to be the vertex. And then we can have a couple points on each side. Now, how many points have I got on my picture so far? Try again. 4. I got 4. I got vertex, y-intercept, x-intercept, x-intercept. So the next and final point that I find, just use symmetry. Just use symmetry, right? It'd be right here. You know what I'm saying? And then we could graph that bad boy out. And there she goes. And that's an example of graphing a parabola using concavity, vertex, x-intercept, y-intercept, axis of symmetry. Okay, I want y'all to practice that for me tonight, leading up to Thursday, and be ready to rock and roll on Thursday. Zach?
What's a good point, Paul?
Just another rando point that's somewhere on the parabola. I recommend just I recommend just pick the one that's symmetrical with the y-intercept.
Would we not have to listen?
Like on Delta Math, they'll actually have you click in that particular location. You know what I mean?
Like this. Excellent.
They'll have you click 1, 2, 3, 4, 5 clicks, and once you click 5 times, they'll draw the parabola themselves. Just make sure you click in the right spot. All right, good job today, fellas. Live Jesus in our hearts.